Hello, how's everybody doing? My name is Riley Harvey,
My name is Sumaya Muri. Hello.
My name is Masai Yusuf Green.
and this is our project on Seaglide. So the marine life on Earth has faced a population decrease due to the massive changes in the overt sound located in the water. These changes occurred due to human impact. According to SeaWestNews.com, more than 3 billion humans eat marine life as a form of protein. Nevertheless, the care that is given to sustain a safe environment, successful reproductive system, and navigation accessibility for marine life is very minimal. This problem can be resolved by implementing our Seaglide in the real world. Using the data that we collect, we can help determine what's in the water and if it's safe for animals and humans. The Seaglide is an underwater glider used to measure different things and assist scientists in learning about the ocean. The device moves when its buoyancy changes, causing the glider to wave in and out of water. The glider changes its weight by taking in water to sink and then releasing water, allowing it to float. On the graph on the side, it shows how the more water that's in the Seaglide allows it to sink, and then the less water is allows it to float. These are our attack points. So the questions that we've been using to help us build our Seaglide is: how will the Seaglide be programmed? What kind of sensors will be used? How can sound be recorded underwater? And what methods of waterproofing will be used for the device? And what is the waterproofing scale?
Here's our design approach. Our main goal is to investigate where human impacts have made it too difficult for marine life to function due to impacts in sound or pressure. To design our Seaglide, we will use the basic instructions from the Seaglide website and modify it to test different things. The instructions include the necessities to create the Seaglide, such as how to construct the engine, bottle preparation, and the Seaglide firmware installation. Materials we will add in addition to the kit necessities are the inclusion of two types of sensors, one to record sound and the other to record pressure, placed on the outside of the Seaglide, along with how different parts will be waterproofed and how the sensors will collect data from the outside and then record information to be utilized later by associations like the EPA. How can this information be utilized? Potential sponsors who can employ this to create better ocean protection acts. Oceanographers, marine conservationists, or the EPA, Environmental Protection Agency. The EPA specifically has already in the past developed acts that have massively improved the protection of marine life that has been put at risk due to human impacts. Examples of this are the Clean Water Act and the Marine Protection Research and Sanctuaries Act, as these acts make ocean dumping and the discharge of pollutants into the water unlawful. Here are some of our milestones. 1, complete research on the topic, brainstorm ideas on how we can get the Seaglide to collect water for salinity, temperature, and noise. Get a Seaglide kit. Build the kit using default instructions. Program Seaglide to research how it works. Using the previous research on the functional Seaglide to create a second prototype, adding the new sensors and parts. See what works and what doesn't work with the second prototype. Make a finished product.
Some feedback that we had to neglect due to complications were questions like, why don't you find a different material that wouldn't hurt the animal if they were to consume the actual Seaglide, or maybe they something that would be sharp, something like that. Answer that we had is that finding a biodegradable option would change too many components, given that the Seaglide that we're using is based on a kit from seaglide.org. Another question is, why don't you look at other Seaglide designs and try to improve from that? Our answer to that was that most Seaglide designs online do not deviate enough from the original concept, which is again on seaglide.org, to be utilized for any type of new approaches to the Seaglide design. Third question was, why don't we just scrap the whole Seaglide idea and just use a camera on a fish to try to record sea information and how it has to do with the actual fauna down there. And our answer was that this could provide a multitude of problems if the camera were to malfunction and hurt the fish. And if we were to utilize it, it would be a separate option from a Seaglide idea that we had. And the last question was, why don't you try to create it from scratch and not with the kit? And our answer was a Seaglide kit from seaglide.org has already done the work necessary to calculate the weight, what is necessary for the parts and the wings to create a stable buoyancy that will provide the Seaglide with propulsion whenever it's changing with the Seaglide wings. For our underwater device, we'll be using a microphone sensor to collect sound waves. This will be able to occur by sound sensor collecting these sound waves and converting them into electrical signals. We will then collect and then store this information using a SD card. An SD card is able to store digital files made up of a NAND chip that allows it to create and store stuff. And the code we've been using, we'll have to use a pause feature to be able to not record the sound of the motor when it's changing the amount of water that's inside the Seaglide. How are we going to get there? We're going to get to our endpoint by fixing our project and making changes to the code to ensure that the microphone works the way it's intended to. Previously, you saw on the slide that we wanted to use salinity and temperature, but due to just the complications with that, we're only able to use sound to be able to work properly. Work completed in the project results. We built 2 Seaglides. We soldered the microphone sensor to the Arduino. We worked on completed the code for our microphone. We worked on the code for the motor, added 3D parts, replaced parts that were worn down, soldered the microphone, communicated on how the Seaglide should be placed, and learning about waterproofing, OSHA training, 3D printing for the overall completion and success of our project. At first, our Seaglide was working when testing how the code interacts with the motor and the microphone, even though we had some complications with 3D parts becoming worn down. Our future innovations, where we want this project to go from here is we want marine scientists and biologists to utilize our project to further understand different aspects of underwater life. By building and improving our Seaglide in a way that's able to function, we want them to be able to collect more data. And a pressure sensor could be added in the future to make this project even further, to kind of push it further, since we already collected sound and we can see how sound levels, how they change from a variety of depths. And that's our project.